Today my topic is RUBP regeneration. RUBP regeneration. So this RUBP regeneration, so this triose phosphate glyceraldehyde 3 phosphate formed by reduction reactions, these are is converted to RUBP by several biochemical reactions. Sugar phosphates with 4, 5, 6, 7 carbon atoms, these are formed as intermediates. Ribulose 5 phosphate formed in the last reaction is converted to RUBP in presence of ATP. So this for the conversion of 6 molecules of ribulose 5 phosphate to RUBP, 6 ATP molecules are required which are derived from light phase. So the carbon dioxide fixation by Kelvid cycle to form one molecule of carbohydrates, 3 ATP and 2 NADPH plus 2 hydrogen plus. Most molecules are required. Most of the plants growing in temperature and tropical regions fix carbon dioxide by Kelvid cycle. Significance, this Kelvid cycle results in the synthesis of carbohydrates. The various intermediates of the cycles are used in the synthesis of several compounds. Phosphoglyceric acid is used for the synthesis of several organic acids and amino acids also, and ATP and NADPH formed in a light phase. These are used to reduce nitrate to ammonia. So the reactions of Kelvid cycles, these are now carboxylation phase. In carboxylation phase, number 1, ribulose 1,5 by base phosphate plus carbon dioxide plus H2O give rise to 2,3 phosphoglycerate plus 2 hydrogen plus. So second reduction phase, 3 phosphoglycerate plus ATP give rise to 3 phosphoglycerate kinase give rise to 1,3 base phosphoglycerate plus ADP. 1,3 biphosphoglycerate plus NADPH plus H plus give rise to glyceraldehyde 3 phosphate plus NADP plus HOPO3 2 minus. Third regeneration phase, glyceraldehyde 3 phosphate give rise to dicarboxy acetone phosphate in triose phosphate isomerase. Glyceraldehyde 3 phosphate plus dihydroxy acetone phosphate give rise to fructose 1,6 biphosphate in aldolose. Fructose 1,6 biphosphate plus H2O give rise to fructose 6 phosphate plus HOPO3 2 minus fructose 6 phosphate plus glyceraldehyde 3 phosphate transketolase give rise to within transketolase. So erythrose 4 phosphate plus xylulose 5 phosphate. Erythrose 4 phosphate plus dicarboxyacetone phosphate pseudoheptulose 175 phosphate. So pseudoheptulose 175 phosphate plus hydrogen give rise to pseudoheptulose 7 phosphate HOPO3. Pseudoheptulose phosphate 7 phosphate plus glyceraldehyde 3 phosphate. Xylulose give rise to ribulose 5 phosphate plus xylulose 5 phosphate. Xylulose 5 phosphate give rise to ribulose 5 phosphate. Ribulose 5 phosphate it gives to ribulose 5 phosphate within in the ribulose 5 phosphate isomerase. So ribulose 5 phosphate plus ATP, ribulose 5 phosphate kinase, ribulose 1,5 base phosphate plus ADP plus H plus. So Kelvin cycle acts in the autocatalytic manner. If the concentration of the intermediates is increased, the rate of cycle is increased and synthesis of carbon dioxide. So acceptor also takes place as a part of cycle. So 5 enzymes of Kelvin cycle, these are regulated in presence of light, Rubisco. So the NAD Rubisco, NADP, glyceraldehyde, 3 phosphate dehydrogenase, fructose 1,6 biphosphate phosphatase, pseudoheptulose 1,7 base phosphate phosphatase, ribulose 5 phosphate kinase. So these the reactions of dark phase Kelvin cycle cannot take place in the dark. So the regulation of Kelvin cycle takes place by two methods. These are, first one is the by altering the enzymes chemically through covalent bonds and disulfide bond reduction, carbamylation of amino groups, conversion of the metabolic products as enzyme homologous by non-covalent changes, and further to increase the efficiency of Kelvin cycle and the Kelvin cycle, the enzymes are bound to thylakoids membrane and achieving high location and act as channels for substrates and protect them. So these are the these are the RUBP regeneration. In RUBP regeneration, these are the triose phosphate formed by reduction reactions is these are converted to RUBP by several biochemical reactions, and sugar phosphate with 4, 5, 6, 7 carbon atoms are formed as a intermediates. So the Kelvin cycle its results in the synthesis of carbohydrates. The various intermediates of the cycles are used in the synthesis of several compounds. Phosphoglyceric acids is used for the synthesis of several organic acids and amino acids. ATP and NADPH formed in light phase. These are used to reduce nitrate to ammonia. So these are the carboxylation phases, first one, and reduction phase is the second one, and the third one is the regeneration phase. So regeneration phase, the Kelvin cycle, and if the concentration of the intermediates is increased, the rate of the cycle is increased, the synthesis of carbon dioxide acceptor also take place takes takes place as a part of the cycle. five enzymes five enzymes of these are uh, these are Kelvid cycle are regulated in presence of light. So these are Rubisco NADP. First one is NADP glyceraldehyde 3 phosphate dehydrogenase. Fructose 1 6 fructose 1 6 uh, base phosphate phosphatase pseudoheptulose. So these are the pseudoheptulose, total 5 enzymes are in Calvin cycle. The regulation of Calvin cycles takes place by two methods. First one, by altering the enzymes chemically through covalent bonds and disulfide bonds reduction, carbamylation of amino groups, conversion of metabolic products as enzyme homologous by non-covalent changes. So these are two methods. So further increase the efficiency of Calvin cycle. The enzymes are bound to thylakoid membranes, achieving high localization and act as channels for substrates and protect them. So these are the RUBP regeneration. So these are in C3 cycles. The different reactions taking place in Kelvin cycles. These are three phases. First one is the carboxylation. Second one is the reduction, and third one is the RUBP regeneration. Carboxylation completed and reduction is completed. Now RUBP regeneration also complete. In these are carbon reactions of photosynthesis. These are almost in first Kelvin identified different reactions in during dark phases of photosynthesis and formation of carbohydrate using of carbon dioxides, radioactive carbon dioxides. So this is in 1961. So in the unicellular algal membrane chlorella, different intermediate compounds, these are separated and identified using chromatography and autoradiography. So the reactions takes place in a cycle manner is and it is called as Kelvid cycle. So the first stable compound formed during this process is C3 acid, identified as phosphoglyceric acid. Hence, the cycle, this process is C3 acid identified as phosphoglyceric acid, and the cycle is also called as C3 cycles. It is also called as reductive pentose phosphate pathway, that is short form RPP pathway. So RPP, R means reductive, P means pentose, P means phosphate. This is called as RPP pathway. It is in C3 cycles. Calvin received a Nobel Prize for explaining these reactions. So the plants with C3 cycles are called as C3 plants. In the beginning, it was assumed that the fixation during the phase of photosynthesis takes place by only one pathway, that is a C3 pathway. Later, an alternative pathway, that is called a C4 pathway, it was also identified. In addition, it is noticed that certain plants open their stomatas during night time and close their stomatas during daytime. So such plants have a different types of carbon fixation which takes place during night time. It is called as dark carbon assimilation. So this crassulation acid metabolism, as it is first described in crassulation members like bryophyllum. So this the carbon assimilation in all plants. These are grouped in three categories: C3 pathway, C4 pathway, CAM pathway. So in C3 pathway, in C3 plants, carboxylation is there, reduction is there, and RUBP regeneration. So carboxylation, the compound which reacts with carbon dioxide intermediately after its entry into the chloroplast, is called as carbon dioxide acceptor. So a carbon dioxide acceptor bind carbon dioxide to form a first stable compound, phosphoglyceric acid. It was assumed that carbon dioxide acceptor might be a carbon dioxide compound and investigated for such a compound and failed to identify such as compound carbon compound ribulose 1,5 base phosphate. So RUBP identified in a later experiments was considered to combine with carbon dioxide to form a unstable carbon intermediate which immediately breaks into two molecules of carbon compounds. So the reactions is catalyzed by RUBP carboxylase. So it is identified that RUBP carboxylase acts as oxygenase, and it high oxygen concentrations. It is also called as RUBP carboxylase oxygenase rubisco. It is a soluble protein present in very high concentration leaves. It constitutes about 40% of the total soluble proteins. So carboxylation results in the formation of C6 carbon 6 unstable compounds which immediately breaks into two molecules. These are 3 phosphoglyceric acids. This is the carboxylation. Next, reduction. In the reduction phase, the the reduction of two molecules of PGA, these are formed during carboxylation. 2 ATP and 2 NADPH are, these are essential. And so 6 carbon atoms and 2 triose phosphate molecules formed. 5 carbon atoms are used for the regeneration of RUBP. So